Hello, this is the second video in the third Matrices series for OCR AS Core Pure Further Mathematics. We will consider the inverse of 2 by 2 matrices in more detail and identify the determinant. In the previous video, we considered t and found t to the minus 1, or the inverse of t, using simultaneous equations. We don't need to do this every time if we use a standard result. If you wish to research for proof of this result, please pause the video to do this now, or follow this up afterwards. For any matrix ABCD, the number AD minus BC is called the determinant of a matrix, and the standard result is that the inverse of a matrix ABCD to the minus 1 equals 1 over that number, determinant AD minus BC, multiplied by D minus C minus BA. You will notice that, in effect, A and D swap places, whilst B and C change signs. So the determinant is a number that may be positive, negative, or 0. Here's an example where the determinant is 0. So you will note that AD minus BC is 1 times 8 minus 2 times 4, which gives us 0. Remember that determinant only exists for square matrices. There are several notations used for determinants of a matrix T in various textbooks. For example, det T equals, in effect, the modulus of T equals the modulus of ABCD, which obviously equals AD minus BC. And the Greek letter delta may also be used. Let's look at these examples. So for A, det of A equals 2 times 4 minus, let's put brackets around that to make it clearer, minus 5 times minus 1. So this would give us 8 plus 5, or 13. I'm using brackets and taking a lot of care with the signs. For B, let's use the notation 2 minus 3, 1 minus 4. For the determinant, we would have minus 8 minus 3. So although I haven't written it out as 2 times minus 4 and then minus 3 times 1, I'm still being really careful with the signs. And that would give me an answer of minus 5. So in this case, the determinant is negative. For C, and I could use det C with this notation, I note that I've got minus 3 times 22, which is minus 66. And then I have minus, and then 7 nines, which is 63. It would be really easy here to assume that those in effect would almost cancel each other out and expect the determinant to be a small number. In this case, it is actually quite a large negative number, minus 129. You should pause the video now and check whether your calculator can work out the determinants for you, and practice these examples using your calculator. Here is another example that you can solve using your calculator to choose whether A, B, C or D is the right answer. Well, we know that the 3 and the minus 7 will swap. So therefore we are looking for minus 7 and 3. And we know the signs of the 8 and the minus 4 will swap. So 4 and minus 8. So this is what we would expect to see as our inverse matrix, but we need 1 over the det as well. It might be that if the determinant is negative, then we move that outside the bracket and change the signs of the other elements. So do watch out for that. In this particular case, we have the determinant being minus 21 minus 32. Which would give us 11. So in this case we've got 1 over 11 and then those elements. which, as you can see, means that the answer here is C. You will probably have been quicker doing that on your calculator. If determinant is not 0, then the inverse does exist, and the matrix is said to be non-singular. This example here has a matrix M as given, and we are told that the determinant is 2, and asked to find the possible values of x. Here we know that the determinant of M will be x minus 2 times x minus 1 minus 1 times minus 4, and that equals 2. This leads us to a quadratic equation in x, where we have x squared minus 3x plus 2. And then being very careful with the signs, we know that we need to take away 4. And we know also that we need to take away another 2 to get an equal to 0 on that side. This leads to x squared minus 3x minus 4 equal to 0, and factorising this leads us to x minus 4 x plus 1 equals 0, giving us x equal to 4 or minus 1. If determinant is 0, then the inverse does not exist, and that matrix is known as singular. Here we have an example where the matrix M as given is singular and asked to find the possible values of k. In this situation, we know that 3 plus k times 2 minus k minus 2 times 3 must equal 0, because singular implies that the determinant is 0. This leads us to 6 minus k squared. And again, being very careful with the signs, plus 6 equal to 0. So in other words, we have that k squared plus k minus 12 equals 0, which factorises to k plus 4, k minus 3 equals 0, thus giving us k equals 3 or minus 4. To find the inverse of a matrix product AB, let's say that x is the inverse of AB, so we know that x times AB must equal the identity matrix. If we post multiply by b to the minus 1, we would have x, a, b, b to the minus 1, which would give us xa, which must therefore equal I, b to the minus 1, or just simply b to the minus 1, as I is the identity matrix. We next post multiply by a to the minus 1. So here we would have x, a to the minus 1, and that must be b to the minus 1, a to the minus 1. But x, a to the minus 1 is simply xi, or just x. Therefore x must be b to the minus 1, a to the minus 1. This is an important result that you need to know. You also need to note that the determinant of a matrix product is the two debts multiplied. So det of AB equals det A multiplied by det B. So in this example here, if we were to look for the determinant of AB, we would need the determinant of A, and in this case det A equals 8 minus minus, in effect, is a plus 5 is 13. And debt B is 8 minus minus, in other words, plus 3 is 11. So debt of AB would be 143. In the next session, we will consider the inverse and determinant of 3 by 3 matrices.